Okay, so I'm going to now do another question of these, and it's going to be question 8, part II. Okay, this one says find the average value of each of these functions. So it gives you fx equals 5 cos x over 2. Sorry. So that's the function there. And it says for where x is less than or equal to 2 pi, greater than or equal to 0. Okay, so straight away it's asking me average value. So I'm going to write down the formula. 1 over b minus a, b to a, fx dx. Okay, so let's just plow ahead and do this then. Now, have your formula books opened, page 26, so you can see how I integrate this. And really watch this, because I know some of you are struggling with the integration of trig functions. Okay, so this will be 1 over 2 pi, 2 pi minus 0, and it's between 2 pi and 0. Remember here, the way they're talking about pi here is we're going to be dealing a lot with radians. Okay, and the function is 5 cos x over 2. Okay, now this here will just become 1 over 2 pi, because it's 2 pi minus 0, which is just 1 over 2 pi. And now I'm going to integrate this. So if I integrate this, it's going to become 5. Cos becomes sine x over 2. And what I need to do then is divide by the number that's in front of x here, which is a half. Okay, so remember x over 2 is the same as a half x. So that's over half. And it's between 2 pi and 0. Okay, now I hope that makes sense, because that's where I think people are getting a bit stuck. So when you're differentiating these, you multiply whatever the number in front of x is here. But sometimes it can be more complicated differentiation. But for integrating, they can only really give you a number in front of the x. So it will be 2x or a half x in this case. Okay, so why is that looking so far out over there? Sorry. Just put it here. Okay, so now what we're going to do is actually the first thing I'm going to do here is this is a bit messy looking. So if I am dividing something by a half, if you remember, it's the same as timesing it by 2, because if you do your division KFC, just write that here. You keep the first, let's say we'll treat these as 2 fractions, keep the first, flip the second, change to multiply. So what this is actually is this multiplied by 2, which you'd agree with me would give you, all of this multiplied by 2 is going to give you 5 by 2, it's going to be 10 sine x over 2. And that is a lot simpler to see and deal with than the above, okay? Hope that makes sense. I've just pointed that that's what I've done to get there. Okay, now I'm going to sub in my 2 pi and my 0. So this 1 over 2 pi will stay in front of each. I'll deal with that in a while. So it'll be 10 sine 2 pi, 2 pi over 2. Okay, and then close that, minus 1 over 2 pi, 10 sine 0 over 2. Okay, now interesting here, and this is why I've picked this one. So far that's going to be the integration, but what we need to be careful of with this one here is this pi in here is the pi that's in the angle, which means this is going to be 180. Whereas this one out here is by itself. It's not attached. It's not part of a trig angle or anything. So that's the pi button in the calculator. Because I know this is something that we can find tricky, and it is tricky. So that's how you remember it. If it's within a trig function, its pi is 180. If it's not and it's outside like this one, this isn't part of a trig function, then it's going to be your 3.14. Okay. Anyway, you'll see here that's going to cancel, by the way. So it's going to be 1 over 2 pi. And it's 10 sine, 10 sine, and it's pi, but remember what I just said, pi is 180, so I'm going to put 180 in there, minus 1 over 2 pi, and what's going to happen with this one is it's 10, and sure, 0 over 2 is just 0, so it's sine 0 degrees. Okay, go to your calculators now, and I'll just write my next line, 1 over 2 pi. Now, if you do sine of 180, you'll get 0. Okay, so this becomes 0, which means 0 by 10 is just 0, which means that by that is just 0. Okay, and over here, you put sine, or 10 sine of 0, you also get 0, which is 0. So your answer here is 0, which seems a bit strange, and I can guarantee you feel like you've done it wrong when you get an answer of 0, and that's a normal thing in maths. But I just want to show you why that is. Sorry, I'm still here. Just want to show you on, oh, this is probably going to be backwards now. No, it's not. Now, I'm going to zoom this into the calculator, or sorry, into the camera. Can you see that this is, by the way, this function, 5 cos x over 2. And that is something probably people need to go over, is graphing trig functions. But this is it. It starts at 1, but there's a 5 in front, so it's up to 5. And there you can see the period goes out, and that's, by the way, 4 pi. This here is, no, yeah, this here is 2 pi, right? So the reason this function, the average height is 0, is because, look, it goes here, it goes down, and it goes down to there. And if you look at that, you can see that the y value, the average of that, is going to be here, which is 0. I couldn't find it right here in your music. Oh, sugar. Sorry, Siri's talking to me. So, yeah, that's why that situation is the way it is that the y value, the average y value height there is 0. So I just wanted to explain that because I could imagine you feeling a bit like, what? Why is that 0? Okay, so that is average value of a function. Okay, what I want you to look at and to try for me is on page 92. I want you to do all of question 2. I want you to do question 3. I want you to do question 5 and question 8 part I. Now there's loads of others there that you can try practice in your own time. Some of them with context, so they might be useful to do too. But that wraps up integration, okay? What I am going to do is just till the end of this video, just talk really quickly just about what I want you to do over Easter. So as I think I mentioned in another video, there are a few kind of small bits we need to tie up, and what I'm going to do is over this weekend I'm going to make videos of them like these videos, and I'm going to upload them onto the YouTube channel for you to do over the 2 weeks when it suits you. It's not going to be at the times that we normally have maths, but I am going to be available for any questions. Like, honestly, the whole of the 2 weeks, sure, there's nothing else to do, isn't there? Not there's nowhere to be going or anything at the moment, so I will be available for any questions at all, whether it's exam questions, whether it's integration, or whether it's the stuff I'm setting you. So what I'll do is I'll actually write down this in Teams. So I will be setting certain work from the videos over the next 2 weeks. It's not going to take you 2 weeks to do this stuff. So you might want to spend a day doing the maths, or you might want to break, like, you know, spend a few, maybe 2 full days doing maths, or you might want to spend an hour a day looking at it, whatever suits you. But it is important that you do it just like these. It's really important you do it, because I don't know I'm watching the news the whole time. I don't know when we're going to be back, so I have to continue teaching. And yeah, that's all. So continue doing exam questions and just link in so you can see the stuff that I'm going to put up. Just so whatever happens in terms of the Leaving Cert and when it happens, or are we back after Easter? Like as it stands, we are, but I mean things keep changing. So anyway, I'm going to stop waffling now and let me know how you get on with these. Okay, best of luck.